guys, welcome back to our Chem 1806 and maybe Chem 1802, but probably mostly Chem 1806. We're going to be continuing on with the second video session of this experiment, but we are going to be starting off at activity 3. Okay, so we're going to be continuing on with the atomic emission and flame test experiment. All right, so if you're watching this video, you should be familiar with what I'm going to be telling you, okay? So if by watching this video, you're going to be getting a lot of notations and a lot of shortcuts that we're going to tell you for this. Activity 3, Dr. Hathcock and I just performed it, and we noticed some issues. We were not able to duplicate the experiment and get the results for what needed to be seen. So therefore, if we're having troubles, you're going to have troubles too. So we're going to modify this a little bit. Okay. You need to have data table 3 in front of you to complete this experiment. Okay. The part up here, color of the flame, you're going to be watching this video. You're going to note that I'm going to do flame tests on 5 different substances. You're going to note the flame color for each one. In each one of those substances, you will then take that flame color, do some research, and come back to this table and identify what substance it will be. Okay. So, in order to make that hopefully a little bit easier of what I just said, okay, I'm going to take the first sample here, it's a white solid, and I'm going to stick this in the flame. Okay. What I want you to know right now is look at the blue color flame, and that's just pure sterno.
Whoops.
Okay.
I zoomed in too far. You're good.
What I'm going to do now is add this to the flame, and you see that reddish color. Okay. That reddish color, that fuchsia red color, belongs to one of these compounds on data table 3. Okay. Oh, there we go. That's really pretty. Okay. So does that red color belong to potassium chloride, lithium chloride, copper chloride, or sodium chloride? Which one of those 4 would give you this red color of a flame? Okay. So that's your first sample. Okay. All right. And I must have spilled a little bit of stuff in there because you can see that red flame. So now I'm going to take this next sample, and I'm going to stick it in this other sterno just to give that other one a chance to burn that red color. Notice that green flame, okay, that bluish green color. Which one of the metals, potassium chloride, lithium chloride, copper chloride, or sodium chloride, would give you that green color flame? This one you might have to look a little closely at. You know, hopefully these flame colors will disappear here. Okay. If you look really close at this one, well, there you go. Accidentally spilled some in there, but now you can really see that color. Which one of those substances, potassium chloride, lithium chloride, copper chloride, or sodium chloride, will give you that purple color of a flame? All right, I'm not sure I really going with that green one again is going to be my best choice. Here's my last known sample, and I'm going to go ahead and try and stick this with copper. Okay. All right, so you notice what the flame looks like now. The green color is because I accidentally spilled some copper sample in there. Okay. This is not quite the easiest method to do. Okay. So ignore that green color. Go with the blue color. Okay. See if I can. Okay, there we go. Hopefully you guys can see that orange color.
There we
Yeah, this one's starting to burn out. The sterno's starting to get a little low. Okay. You can see the orange color? That's one of your samples. Which one is going to give you that orange, yellow, that orangish color?
Okay.
That works. So, you got four flames, okay? 4 flame colors that you have to identify. So the question is, you've seen those 4 colors. Those 4 colors correspond to one of those compounds on data table 3. Okay. All right, I think my best choice now is to go with that one that's still burning purple.
It looks blue.
Okay.
And your sterno burns blue, by the way.
Yes. The burning of the blue is because sterno is ethanol, and ethanol is very flammable. All right. Okay. Now, in order to do this sample, you need to know the colors of the flame. So potassium chloride will burn what color, sodium chloride will burn what color. Okay. Because in this cup here, it's a white solid. Okay. And if you were watching carefully, that would eliminate one of the samples already. Okay. But I'm going to take this white solid, okay, and this is your unknown. So based on your observations for what we just did earlier, you can take this flame color and you can say the unknown is potassium chloride, okay, or is it sodium chloride. The flame color should match. So I'm burning the unknown. Okay. So if you go back through your results, okay, you go back through our video, look at your table, what compound would give you that reddish color that is burning? And then that would tell you the unknown and what substance this compound right here is. All right, so that's going to be the flame test. Now, the idea for the rest of this table was that we would take your sticks, burn them. While your stick was burning, you would look through your spectroscope and see if you could see a line. If I can do this without making a mess. You would see something that looks like this. Now, this is not what you would see, but you would see these lines. Okay. Each sample is different, so you may see 1 line. You may see 2 lines. Okay. But you should see at least one line. Okay. But we couldn't get the colors bright enough to appear through here. So that made it a little bit difficult. Now, you do have some sticks. You should have 5 of them. Feel free to burn these in sterno and attempt to look through this. Do it for your pleasure. Experiment with it. You've got the sticks. Okay. What I'm going to do and what you need to do is pay attention to somewhere within your experiment, maybe one of the questions. Okay. I will give you some values. Okay. You will know where this question is. I may give you a partially completed table, but what I'm going to do is I'm going to give you a spectrum line number. In your lab, in your module, there is an equation on how to do this. There is a sample problem. I'm going to give you a spectrum line number. you need to use your calibration curve and determine what wavelength that will correspond to. Then you can identify what color that line should be. So if it's 4.8 on a calibration curve, does that match a wavelength of 656? And if that does, then what color should that 656 nanometer wavelength be? Okay. Now, I just threw that out there, so that's not by any means of what you should happen, but I will give you line spectrum numbers, and I will expect you to use your calibration curves to go back, determine the wavelength, and then tell me what that color should be. Okay. Then, on this part, on activity 4, you have your wavelengths. You need to calculate the wavelength in nanometers, so make sure you're aware of that conversion. You will need to calculate the change of energy, and then you will need to tell me which energy level did that electron start from. So all these electrons, to be in the visible spectrum, have to end in energy level 2. That's where their final place will be. Okay. If they end up in energy level 1 or energy level 3, that's going to be in the infrared or UV section of the electromagnetic spectrum, so we cannot see that portion. Okay. So to give you an idea, to help you out, all your final energy level values must be 2. Then you've got your wavelength, you've got Planck's constant, so you need to calculate the change of energy, and then go back, look at that module, because it works you through how to do this. But you're going to do this 4 times. And then tell me, where did those electrons, which energy level did they start with? Okay. Again, on data table 3, okay, you're going to find the spectrum line numbers for this table in your lab. Okay. It'll be towards the top of your experiment, so you will be able to find them easily, but you will need to tell me what color of line these correlate to. Okay. So if you have any questions, please feel free to email me through Canvas, and I will be glad to help you. But good luck until next time.